Welcome back, guys. So, yesterday was a disaster. We were not able to make most of it. We managed to write a little bit of F open to build all the things that we have wrote the previous week, and this is what we have so far. But overall, today I want to manage to fully compile this entire setup and try to open a file and see if we are able to do it. And yeah, that should be the thing for today. And overall, we have been trying to write our own kernel, and we have been successfully uh, done with the memory management unit and syscalls, switching between user space and kernel space, and overall the block layer. And we also have a virtual space, and we have most of it working today. We are trying to get the VFS layer working. For past few weeks we have converted the theory of X4 frontend into actual code, and yesterday we managed to make it compile. Today we have to make it work, so we actually have a file open. That's the thing for today. So yeah, let's get started then. So what do we have? Yesterday was we just what we did is that we ran the codes. Let's see. So now we don't have any compiler errors. It runs and we reach the particular location that is here, and we try to open it and nothing else works after that. So that's fine. At least we don't have any syntax errors and the code is fine. Now we just have to make the logic work and probably fix things around it. So in general, from file open point of view, as soon as we say that you want to open a file, it has to first go to the root node, because root node is the one that actually has the other directories within it. So here we are assuming that root node is in inode 2. So first of all we pass 2 and we get the actual inode struct for that number. Within that inode structure, we should have the inode block is just the initial 60 bytes of data that has the extend header and the extend entries. So we get the block of bytes, we parse it, we send it to our helper that is just going to take the parse, and we have a result out of it. Once we have the results, we should be actually able to go into every result and get the physical block and group them together into one single byte, because every result block within this is actually an extent entry. So every extent entry should actually have some logical blocks and the respective physical blocks, and everything is related to a single file. Yeah, let's just type it down today. Let's make F open work setup. I just typed down in the chat so that we know what we are doing today. Okay, at least the flow looks fine, and as soon as we run the code, it does not seem to be working, and it did not work even reach the first printf. That means the first code already failed for some reason. We'll see what happened there. going to be 2. Okay, just to be sure, let's run it, and we know that we can reach here, and this call is not working, so let's get into it. This is inode to inode number. So what it's supposed to do is that it takes an actual number and converts it into an actual inode struct. And inode struct should have a lot of things. Let's check what it's supposed to have. It does not have. There's group descriptor table, and this is the inode. So inode is supposed to have lots of these entries, but in our case it should have the inode mode. That's the current mode, and the inode block. So this is the inode block, which is of 60 bytes, which will have the extend headers and its entries, and we just recursively go through all the entries. Currently it would just have the 60 bytes of entries, and that is all we have parsed. So from the entire inode list we only parse 2 fields. That's enough. We are not going to care about the rest of the fields. Yes, we're not going to care about the rest of the fields. I think we don't have to. Looks, I know, blocks of physical. I think we don't have to care about it. So the actual logic goes like this. So we get the inode per group, which is an value that we must have parsed from the initial block. If we know the inode per group, and we also know the inode size is that a single inode can have of certain bytes. So we also know the inode size. This is also being passed from probably from the super block, and then we can just give the current inode divided by the number of inodes per group. That would give us the actual group that our inode belongs to, and we can also divide it. No, we can get the numerator to actually get the relative index within a group, because we know that, let's say we got 5 in this. That does not mean the actual inode is within the actual inode is within the 5th group, but within the 5th group probably we have multiple inodes and we need the index. So that's why we use the inode per group. So a single group can have as much as inodes, and we just use the reminder operation to get that relative index. Okay, so that's fine. What else do we do? Okay, now we just take the actual inode table of that group. So we are taking, here we have found the group number. So as we mentioned from the initial block, we would have gotten every group's inode table's physical block number. So this is what that is being actually stored here. So we have a global pointer of all groups, and every group's inode table's physical block is being stored. We parse this from the probably, I guess, from block 1, and we can just now read that table block into a buffer and use that as the base address to get the relay, and we know the relative index. So now we have the actual data. Within that data we actually have the I block is of offset 28, so we converted it into that, and nothing much. We just send that back to the user as the result. So right now let's see probably which operations might have failed. Is that maybe this one failed, maybe we don't have a global pointer at all. Let's see. I'm assuming we should have, because we already mounted the file system. Only after that we are trying to do these operations. Okay, so we here we say no, not printf, trying to get the group inode table. Let's see if we have x4 global pointer. First of all, let's see if that is set. Next thing we can do is that we can also try to check the group to see if there is anything inside there, and after that probably we can say group dot inode. Okay, maybe this is the issue. I didn't access it properly. Then how the fuck did it compile? I was hoping that if it compiles, then probably nothing is wrong. Okay, we have 0th index with this, first index is this, and second index. Okay, dash build. Okay, we are not even crossing this properly. We have to print maybe it's just that the global value is not there. It's possible, but I don't know why it's possible. We'll decide that. Okay, so the group inode table is there. Okay, so the next thing we are trying to do is that for that inodes per group, we take the 0th group's super blocks inode group, because we know that 0th group is the one actually has the super block. Every other group will have this field in my case, but then the field would not have any value in it. Global x pointer, x4 pointer. So this is what we saved as soon as we what is it, we mounted the entire file system. So we have the mount x4 file system, and the end result is that we just store this as a global pointer. Okay, and the second thing should be groups pointer to groups, g pointer to groups. Let's see if we have it. Groups, and let's say if we have the 0th group. Okay, so we do have 0th group. Okay, maybe the next thing to test is the 0th group does not have super block. Okay, the 0th group does not have any super block value. So what the fuck are we doing? Where do we parse super block? Here we parse it. We have the mount x4. So what we do is within mount x4, we start by reading the 0th block. We read it and we confirm that it has certain bytes, which is the magic number. After that, we get the logical block size from a specific offset. We also get some other values. Okay. Okay, we have the super block here. We are assigning super block values here. So I'm pretty sure we parse these values properly, and so we do have assigned it properly, and then based on the number of groups, we set up the group. But then here only thing we are accessing currently is just super block, so only the super block should work fine. So let's just add the print messages here to see if they are actually accessible, to confirm them. So we have the super block, so we have super block count, and we can copy it and we paste it 5 times, and then we add what we want. We want block count, and then we want blocks per group, and then we have inodes per group, and then we have inode size, and we have number of groups. Number of groups, inode size, and then we have inodes per group and block counts lower. Why do we have blocks per group as blocks count lower? Block count is this. We have grouped it into a single single 32 into 32. And blocks per group. I think it's this value. Oh shit, it should be blocks per group. Okay. Okay, let's run it and see what is there. First of all, do we even have everything parsed? I mean, I'm hoping we do. So we have a block count of this. Blocks per group is this, it's fine. Inodes per group is fine. Inode size is 256, fine. Number of groups is fine. So here, when we actually parse it, we have the proper values, and then we set groups. We parse the block, and then we create a group pointer, and we set that as, and it must have been the first block. Maybe this group is not attached anywhere. Yes, we have the x4, and x4 has groups here, and no, it's correct. So here we have the x4 group as the base, and we just use base plus I. Maybe this operation is wrong. Yes. I think it should have been like, it's already allocated, right? We have size allocated, so that means we have to use size of x4 group into I. So this should be the actual logic. So I guess I messed up there. Okay, now at least we have the groups. We consider them as the actual values, and we update it. Yes, it should be fine. It should be perfectly fine. Maybe let's try to access it here. Let's say here we paste it, and we go to visual block, fuck me block. Okay, whatever. And we want to add what? X4 groups of zeroth group. Zeroth group super block. This is what we want. So let's just copy this and paste it. Now I have to paste it here. Okay, I think I pasted here. I just put super here. Let's see if the pointer actually has anything. What the fuck happened? No, it does not. So something is happening here. So we print this, and this is where we are failing. Okay, probably because parse GDT block. Okay, we will come back there then. Let's save this and close this just to be sure. Let's run it again. Okay, so we only have one block. Here let's go to GDT block. So for every group we also have to parse that particular group's GDT table. No, right? We have to parse the that particular group's inode bitmap and block bitmap and inode table. We want to parse these three values. GDT is only for block 2. Okay. Here we are always passing block 1. That's not good. So what do we do here? We have to parse GDT block. That is global descriptor table, and it's in the first logical block. Maybe it's the size that is. Let's see. You are printf current index, and let's see, should be current index star descriptor size. Maybe we just don't have enough space. Looks like no. Even here, GDT block parsing for index. And it's current index. Okay, let's see if we have it there. No, we did not reach that. So something else is wrong. So we are here. We are able to print this, but we never get into this. That's so fucking bad. Oh shit. Why do I make so fucking dumb mistakes? Yeah, now it's able to go into index 0. Now we are reading the bytes. Okay, that's working now. Oh, we are missing something, but I'm not sure what the fuck are we missing, because right now the previous mistake was just that I did not initialize the int value, so we were not able to just continue because that condition will always fail. I just had to initialize it, so that's fine. That's done. I think maybe for past GDT I have to start from 1, because there's no such thing as zeroth group. I mean, there is zeroth group, but first of all, where are we stuck first? We are stuck reading the data. And what do we want to read? We want to read zeroth block. No, we want to read the first block. Why is it hard to read the first block? Hi. Yeah, I'm trying to fix my extent for front end parsing, and yeah, it's just I've wrote the code, but the code is still not fucking working. It's just part of the overall file system layer for my kernel. So we have block reads, and block read I'm just passing 1, and I have a buffer. My block read is fucked up for some reason. Okay, I can do one thing. I can remove this test calls to see if that makes any difference. fuck happened? Okay, I have to also remove this. Okay. Okay, fuck it. Entire system collapsed. Probably my entire setup was hanging on this thing to work. Oh, sad. How sad. Yeah, I'm just trying to read from this blog. Nothing much. Don't do anything else. I thought maybe if there's anything, and as soon as I read that blog, it's starting to work. That's just so fucking annoying. Okay, now we have to figure out exactly why we are stuck here, and then we have to decide. We are reading block 1. That is all. So, literally, something is wrong with my block layer. That means. Okay, let's go to current index then. Let's see what the fuck is wrong there. Has current index. We have status bit 2. What the fuck is current index? Let's search for all current index. So we have 2 current index. We have one here. There's no total allocated before that, so probably there is this current index. So block read worked fine. The current index is the one that is fucking up. Why is current index this big? What the fuck is my current index? So it's not my block layer, it's just my fucking, because I'm pretty sure this should fail because I have only assigned 496. So if we try to read past it, so it is going to fail. One. So our block sizes, descriptor sizes. No, that's wrong. What's my descriptor size? Wait. Let's go here. No, not this. Yeah, yes. We have the descriptor size. Where did we parse it? Okay. A single descriptor size, right? That means I fucking forgot what the fuck is a descriptor here. Oh shit. We have to go back to our theory. Let's go back to fucking. Can't find it. Okay. Okay, here's our entire logic that we want to put together. It's actually a uint 16 value. It's supposed to be uint 16, but I'm reading uint 32. What the fuck is wrong with me? Why the fuck did I put uint 16 here? And did I even check what I got? Go back to 0 or 2. What is my descriptor size? Descriptor size is 7, 8. What should we normal descriptor size? Let's see what happens there. Let's see, a descriptor size should be like 32 or 64, but I have 76,000. What the fuck? So probably I have to let's put you in 16 and put you in 16 here and go back to our implementation. Assets and put you in 16. Let's see what we get here now. What the fuck? Sometimes my switching simply does not work. I don't know why. Let's see. What's the descriptor size? That is what I have to first confirm. Where is my fucking descriptor? Oh my god, that's just too much. Okay, we have mount x4. Okay, now the current descriptor size is 64. Okay, because of single error we fucked up big time. Okay, so now we have a different error, so we are somewhere here. and we get extent magic bytes did not match. Okay, so let's go there. I guess I have to put some flag to remove the block level logs and only have it when I actually need it. Right now it's just simply too much logs, because almost for every block read I have like around 50 to 60 logs. Okay, we have the past GDT. I can remove this. Maybe it actually decided to return something. This is just too much logs. What I need is, I'm currently in my block read 1 and I have the current index. Here I'm failing because my okay, here we are still failing here. So that's why we tried to see if we are actually parsing the GDT properly. Current index inside parse GDT. Let's see if these values are actually here. GDT parsed block bitmap, and we have inode bitmap, and we have inode table. Okay, let's see. Okay, so we are passing something. So pass GDT is kind of working. Let's put final. Oh shit. How the fuck do we... This is how we lost the previous information probably, because yesterday I had to go through a lot to bring back all those stuff. So randomly I must have clicked something and it must have removed a lot of stuff, and I didn't notice it. It's final parsed. Okay, now let's build it. Okay, so we do have final parsed, so the values are there, and then we done mounting x4 file system, and then we move to global pointer and global groups. Probably the group value is the issue. What is the fucking group value? Current group. Okay, let's see. Current group is 0. Why can't 0 is 1? 0 should have been the initial group, and here when we try to get the group super block, we are using group as 0. Okay, here we are trying to take the inode table of that group. What is this group supposed to have? We have ext4 pointer. I think it's the pointer arithmetic because we are directly indexing it. It's not working. Wait, how do we assign it? So we have this, and then for the groups we assign entire size with this way. Yeah, probably that's the issue. I'm not sure. So let's just try it. Let's just try to manually. So instead of taking it as group, we take group into size of group extend for group group plus size of into which group. We need the 0th group. This arithmetic should give the proper thing. So if I change this back to this, so we have x4 groups plus size of x4 group into the group number and we can make that as extend for group pointer. What's the error? Oh, what's the brackets? Now I can take table. Let's see. What the fuck? Is the uint64 value? We have extend for groups plus uint64. This entire thing is a mess. Let's just drop it down and write it separately. So we want an extend ext4 group which is temp equal to extend for global pointer and groups. So we have the groups. Now we need current group. Current group equal to, we have the starting address. If we directly do pointer arithmetic to an existing structure, will it automatically take the size and add it? I think so, but I don't know. So that's why I'm just going to first of all convert it into this, and then I'm gonna plus size of extent for group into group. Now I have a size. Now I can just text for it. Probably just indexing should work, but I'm paranoid about it, so yeah. Hi. There must be lots of channels. Okay, thank you. Yes, currently we are writing our file system. And now I can just say current group inode table. This is what I wanted to achieve. And I got an error. Why? I don't know. Okay, now the group table, there is something. But both values look exactly the same. What the fuck? That's not good. What the fuck is this? How did I index the global pointer directly? I must be so fucking stupid. That is the groups. Okay, here I'm in accessing 0th group. That's why. Fine. If it's 0th group, then this entire operation should be 0. And that's why it is 0. Fine. Okay, we get it. And then we try to read a block number. Which block number are we trying to read here? We are again trying to read the 0th block. Okay. We try to read the 0th block. Inode size into relative index. I need to make sure that value is not going past 4096, because we only have 4096, and if we try to index something that is beyond that, it's going to be an issue. Hi. Yes, I'm trying to still fix things up here. So right now, yeah, we almost managed to um, get through half of it. We'll see. I'm still trying to debug things. So here I am. I have the inode table block. I need to check if my relative index is fine. So let's see. Indexing within block with relative index, and let's try what that is. It should be inode size into relative. This should be less than 4096. If not, things gonna be messed up. Where the fuck is that? Where should I see this log? After trying to get, I get the block read requests. Okay, here it is, indexing within the block. So the relative index is just 512. So I think that is also fine. So we are indexing some around 512 block, and then we have we are trying to get the mode, and we get the block. Okay, so we have returned from this block. Okay, fine. So we can go back to our here. Yeah, here we have returned, and the root inode. Did we return? We should have, because we have the relative index. Yes, we have the root inode. Let's just put L here. Yeah, it should be easier to find. Yeah, we have the root inode here. So we did move past that. Okay, now where are we? Now we have the result block, and we have read. Okay, so now we are inside parse extend block. Okay, so once we have the root node, so we start from file open. This is what we want to implement. So if the file is etc password, so we know that we have to start from the root inode, and the root inode is always the same, and it's going to have the number 2. So we start by reading that inode. We get the inode struct for that. So this is what we have finished so far, and within that inode we have the inode block. Inode block is going to have the extend headers and extend entries. So we want to parse it, so we parse it to our helper, which is going to just take inode block and this result, and this result is just going to have all the extents. So now if we go into our parse extend block, here the moment we get into it, we first of all check the header, and looks like the header is not equal to this value. So let's see, let's put you on printf header magic bytes, and let's see, let's put It's going to be character pointer, so I need to convert it into for int I equal to 0 less than let's just print 15. No, let's just print 5 plus plus, and let's just take this, put it here, push it down and put D here. Now we can just print every character as ASCII, and it should be character I block of I. Let's see. We have zeros, and that's why it's fucking not working. First of all, why the fuck do we have zeros here? That's something that's not correct. Okay, let's go back to our inode block. Here we read the entire block. Okay, let's just test what is the block number. You want printf block number for inode, and our inode is, and our block number is, and it's going to be inode and inode table block. Okay, let's see. It must be here somewhere. It must be before that block reads. Wait, it should be index, relative index, something like that. Oh, I fucking hate this block layer error messages. Oh my god, I'm running out of time. Okay, we have the relative index here. So this is this block read, all the logs. And if we move past that, we have we have it here. So we have the block number is 0, and I know table block is 0, which is wrong probably. Current group's inode table is not supposed to be 0. Something is fucked up here. Something is fucked up in this logic. So what we have the global pointer, and within the global pointer we have groups, and the groups have super block. and we know the current group is 0. And we specifically mention it as this way, mention it this way, so we know for sure we are getting the 0th group. Also in our case it's just 0, so we could just use this. And we are using current group dots. I know table. It's correct. It within x4. Yeah, we start from 0. Let's see, parse GDT. We do have certain values correct. Let's see. Let's put the current index. And it's going to be T for index T for index T. And it's going to be current index, comma, current index, comma, and current index, comma, I know table. Okay. Maybe let's just print it if the index is 0. We will only have one thing to look for. Current index equal to 0. We can move this here. If we bash build it. Oh, I fucking forgot how to search within Temex. It should be something like this. Why is it asking key? It should be something like as the fucking search. It's yuff. Fuck. But it's fucking find window. Oh my fucking god. How do I fucking search for a plane? I know for sure there's a search operation. I just forgot. What the fuck I have to type there? Okay, fuck it. Maybe I just have to put this. Nope. Oh shit. Okay, fuck it. I guess we have to just go through it manually. Where is GDT parse? Okay. For the first block, we have zeros here, so the issue is already here. So it's not an issue with the project for my third year of college. Okay, so suggest you projects. So, but I need to know what you actually like to do before even I can understand what I can suggest you. What do you like to do first of all? What's going on here? I'm just trying to fix my extend for parsing. I'm trying to read the what's that particular INO table for my group 0, but for some reason my group 0, all the three values are zeros, and I have no idea why. I'm just trying to figure it out. I have no idea what this. I only know how a little bit of how LLMs works. Nothing much. I have no idea of AI ML fields. But if you want to do something, maybe you can try. What's interesting currently? I'm not sure about exactly about MLAI, but I recently read about something called what's it? I fucking forgot the name. CLX, I guess. Let's search for it. Improvements for memory for LLM. Yes, this is the one. You can try this out. So what it is, it's you can try this. This is called CLX memory. So because LLMs need really good bandwidth, so one of the no, I'm not creating my own OS. I'm creating my own kernel. So here so you can just try this setup. It's called CLX memory. So language models need enough bandwidth, and currently one of the bottleneck is that the amount of time it takes to actually reach certain hardware is really slow. So they have come up with this new hardware that will pool the entire um, hardware. So we'll get a virtual interface for the hardware, and you can just use it like a virtual memory, and you won't be waiting for hardware, some things like that. You can just check it out. I'm not exactly sure, but it's really good. I recently read about it. It's this. Why can't I paste? You can just type CLX. It should be come up. It should come up. But I read it somewhere. But yeah, I guess something like this. So currently the bandwidth between the actual CPU and actually accessing the real hardware is too slow. So um, they have implemented this virtual layer that can just help us make it faster somehow. But I don't know how it works, but I don't know. I know that it works. And currently, almost many big data centers are moving to this architecture, so you can maybe talk about it, maybe you can implement something on top of it, and maybe you can test and show the difference, things like that. Yeah. Yes, and let me know if it's better or not. Yes, in a way we are just interacting with the CLX memory instead of actually interacting with the hardware. Okay, whatever. Uh, mm, where did I leave? I fucking forgot what I was doing. Okay. I guess I was checking why my tables are 0 for this index, and I'm not sure why. That's what we have to figure out. Okay, we come here, we check this, it should be 0, current index. Okay, now I understand. We are reading the entire block, which is the first block, and we know that the first block is GDT, and descriptor size into that means this buffer should actually have something or not. I don't know, we'll see. For I could see what was done. 4096 So here we just print UART print and just print D and which space of I. Let's see what the fuck is inside that, and then we can put UART print of let's put something big in front so that we can see it easily. Here. Okay, that should be big enough. what the fuck is this? Yeah, we have a base. Oh, it's base. Need buff. Maybe what we have to do is that for at least for the first index alone, we have to skip the top bits. Okay, so if index equal to current index equal to 0, that means I just change buff plus I don't have to change that. I can just change this. Put here. Put it here. Plus 1, 0, 2, 4. Because the first group has zeros in the front. What's wrong? I have base. Here. Why is base undefined? Maybe because it's because of the scope. Now we are fucked up right after we read this. Okay, it's even worse now. Okay guys, it's been 1 hour 30 minutes and I'm gonna stop now because my fucking brain is not working anymore. The moment I moved it, I'm getting killed somewhere here because this is getting printed and one of this operation is fucked because we don't see this message. We just see the entire block 1. Okay, so let's write down what to do here. To do confirm where we can get the GDT for group 1 or maybe group 0 should not have it. We should supposed to skip it. Okay, and here after we moved past 1024, we are getting some wrong memory error probably. So check where to read this properly. Okay, I'll try to see this next week. Thank you guys. I'll see you next week. Bye bye.